Okay, we've been discussing patterns of resonance, and items number 3 and 4 involve simply just breaking a pi bond or forming a pi bond. Okay, breaking a pi bond or forming a pi bond. Now, and they're kind of like flip sides of the same coin, so that's why I combine them here together. So let's look at some examples of this and discuss a bit about it. So, all right, so here's a molecule, and we want to draw a resonance structure for this, and you're thinking, well, I don't see a lone pair next to a pi bond. I do see a lone pair, but all you see is a pi bond, and now you do see a positive charge. And so what you want to get in the habit of thinking in the organic chemistry course is the following. If you were an electron, where would you want to go? So these electrons are already on the oxygen, these lone pairs. So these bonding electrons, what if we took those and moved them up? Well, we could do that. Remember, only pi bonds can move, so-called move in a resonance or be involved in resonance. And if I do that, the top oxygen atom here is going to have 2 lone pairs, and the bottom carbon is not going to have any. So working with formal charge, the head of the arrow becomes more negative, so that changes from a plus to a 0 charge. And the foot of the arrow becomes more positive, so the bottom carbon now needs to be shown as a positive. Okay? So this is a very valid resonance to draw in organic chemistry class. Example 2. I'm just drawing H's because they're a little bit smaller and easier to draw than big old CH3 groups. But let's look at this functional group here. We'll learn about this in the second semester organic chemistry course. But again, we have a situation where we're asked to draw a resonance, and there's not much we can do. We could move this up like so and draw the electrons residing on this nitrogen atom. We don't talk about nitrogen much in the first semester, but recall that nitrogen with 3 bonds is neutral, so that nitrogen has a formal charge of 0, and the bottom carbon with 3 bonds must be a formal charge of +1. Okay? Let's look at one more example. Let's look at a neutral organic molecule. Okay, and we are asked to draw a resonance structure for this. Now again, you want to ask, if you were an electron, where would you go? And you want to think about electronegativity. The oxygen atom is more negative than carbon, and so it likes electrons more than oxygen. Okay, so we will first, let's draw the lone pairs on the oxygen just to help us with electron accounting. And now let's draw these pi bonds moving up to the oxygen. Let's worry about formal charges now. So carbon with only 3 bonds is plus, oxygen with only 1 bond is negative. The other way you can figure that out is look at the arrow. The arrow is pointing to the O, so it's negative. The arrow is coming from the carbon, so it's positive. Okay, so that's the basics of that. So let me give you your problems to work on here. Um, Okay, this has one additional problem, one additional resonance structure that you can draw. This has one additional resonance structure you can draw. Okay, and let's do maybe another one. Yeah, so this one will have one additional resonance structure you can draw. Okay, so print those out and do that worksheet if you're in my course. If you're watching YouTube and you're not in my class, work on these yourselves and ask a friend, a teacher, or a tutor to check your work. All right, so that's the patterns 3 and 4. Thanks for watching.